through 10 here? Okay, that's not through 10. Okay, then I'm going to start reading your answers at 12. Number 12, you should have 4. 14 is 4. 16 is 7.2. 18, 7.5. And 20 is 7. Good on those ones? 21, 125 miles. Okay. To 25, your dimensions of your scale drawing should be 18 inches by 22.5 inches. How do I do that one? So my room is 12 feet by 15 feet, and it's like I'm going reverse. I'm going to put it onto like a blueprint. And I'm going to use the scale that for every 2 feet, it's 3 inches on the paper. Okay, so like in your head, if there's 12 feet, right, and every 2 of them are 3 inches, how many 2 feet are in 12 feet? You know how many 2 feet groups are in 12 feet? 6. Okay, so now you take 6 times 3 to figure out how many inches that is. Because it's for every 2 feet that exist here, that's 3 inches on the paper. Or you can set up a proportion. Here is my starting ratio. 3 inches to 2 feet is the same as X amount of inches in 12 feet, which is the same as Y amount of inches in 15 feet. We can actually make it an extended proportion so that you can solve for X and Y at the same time. X would be 18 inches, and then Y would give you 22.5 inches when you cross multiply. Okay. 26, find the ratio of the longer side to the shorter side. So when you reduce that, you should get 13 to 6. 27, 5 to 4, and 28 should be 4 to 3. From the longer side to the shorter side. So this side is longer than this one. So you would write 65 over 30, and then just reduce that by 5. And 28, this is 2 feet. So we have to make sure we put them in the same unit of measure, which would make that 24 inches. So then your longer side to your shorter side would be 24 over 18. Reduced by 6, and then you get 4 to 3 as your final answer. Yeah, that'd make it huge, huh? Yeah. 29, you should have A as an apple. I'm going to skip the next 4 and jump down to the last 8 here on this page. 35 is 6. 36 is 32. 37, 16.5. 38 is 6. 39, 4. 40, 12/19. If you attempted 41, you should get 2 answers, 4 and -3. And if you attempted 42, you should also have 2 answers, 1/2 and -5/6. I'm going to do those 2, regardless if you tried them or not. So, just add it on here. For 41, x minus 3 over 3 equals 2 over x plus 2. Okay, cross multiply, since it's a proportion. And your extremes that you're multiplying are going to be, bless you, these guys. So then x minus 3 times the quantity x plus 2 equals your means, which would give you 6. You have to distribute twice, because you have 2 terms out front. Distribute your x. What's x times x? Good. X times 2. 2x. Now I have to distribute the -3. So -3 times x is -3x. -6 times 2 is -6. That's foiling from last year. First terms, outside terms, inside terms, last terms. Okay. When you have a squared term, you want to bring everything to the same side. So I'm going to subtract the 6 over to the left side. And this is x squared minus x minus 12 equals 0. Now to find your solutions, you have to go and break it back into 2 parentheses, which is called factoring. We had one problem last week that we did this on a worksheet. This times this has to give me x squared. So what are we going to put in those two spots? X and x, good. This times this has to give me 12. 4 and 3, okay? Now you check to get your inside term. 3x and 4x. Can I combine those to make -1? Yeah, which one has to be negative? The 4. -4 and +3 gives me -1. So up here I make it -4 and +3. Zero product property. Something times something equals 0. So then one of these has to be what? If you multiply two things and get 0, one of them has to be what? 0, right? So what you do is you set the expression on the inside equal to 0 to find out when that happens. Add 4 over, x equals 4. Subtract 3 over, x equals -3. Those are the two x values that will give you 0 up here to make your solution 0. So you should check these. I did earlier. They both work. Okay. I'm going to do the next one with you, 242. Thanks. 3x minus 4 over, no, 3 minus 4x. 1 plus 5x. 1 over 2x plus 3. So again, multiply your extremes. So 3 minus 4x times the quantity, I did it again, didn't I? 2 plus 3x. 2 plus 3x equals the product of your means, so 1 plus 5x. And then FOIL, distribute twice. 3 times 2 is 6. 3 times 3x is 9x. -4x times 2, -8x. -4x times 3 is a -12x squared. Your squared term's on the left, so I'm going to bring everything else to the left. So I'm going to subtract 1 and 5x's over. 6 minus 1 is 5. Up here, 9 minus 8x is 1x. 1x minus 5 would give me -4x, right? And then minus 12x squared equals 0, because I took them away over there. Once you have it equal to 0, that's when you go to break it into the two parentheses. This is when we factor. First term times first term has to give me 5. 1 and 5. Second term times the second term has to give me 12x squared. Okay. Yeah, throw my x's on there, right? So I get the x squared. Then we check it. 3x, 20x. Can I combine 20 and 3 to get -4? This is my goal. I'm trying to get to that. Probably not, right? No. Okay. So we could switch these. Make it 3 and 4. Then that gives me 15x and 4x. Will 15 and 4 bring me to -4? Probably not, right? Okay. Try 6 and 2. 6x, 2x. 30 and 2. That won't really. Okay, let's flip it one more time. 2 and 6. Now this gives me 10x and 6x. Will that give me to -4? Which one has to be negative? -10. So which do I have to make negative up here? 2 or 6? 2. Good. Once you have it factored, well, then you take the expressions on the inside and set them equal to 0. So 1 minus 2x equals 0. 5 plus 6x equals 0. And then you just finish solving for x. Add your terms over and divide by the other one. So students at the U of M built a model globe 42 feet in diameter. My room is 20 feet. So like think of two of my rooms. That's how big this globe is. It's huge. It's huge. That far across and that far up and down. Exactly, right? Okay. So they're using a scale of 1 to 1 million. So like for every 1 foot on the globe, that's 1,000,000 feet in real life. Mount Everest is 29,000 feet in real life. They want to know how high it is on the globe then. What do you think we have to set up? A proportion, yeah, that's what we're doing. They give us our starting ratio, 1 to 1 million. 1, does it represent the model or real life? Model. So if I'm trying to find the height on the model, should I put my x in the numerator or the denominator? Numerator, because these two things go with the model. 1 million is real life. Well, in real life, Mount Everest is 29,000 feet high. Cross multiply. And you get 29,000 equals 1 million x. So then we have to divide by 1 million. And when you do that in your calculator, you get 0.029 feet. So like 29 thousandths of a foot. Does that make a lot of sense to you? Doesn't make a lot of sense to me. But if I convert this to inches, how would I convert this to inches? Okay, so when I take 0.029 times 12, I get 0.348 inches. 0.3, what fraction goes with 0.3? What? 3/10 technically, 1/3, yeah, 0.3 repeating is 1/3. Doesn't a third of an inch make more sense than 29 thousandths of a foot? Okay, so Mount Everest on that 42 diameter globe pops off just 1/3 of an inch. It's probably less than your nose is poking off of your face. Unless you have a really tiny nose. Neat, huh? Yeah, I know. I think it's cool. These ones down here, you can do one of two things. You can put an x and a y in there and just solve it as an extended proportion. Or, since you're trying to make them all equivalent, do that. Reduce this thing. What's 8 over 12 reduced to? 2/3? Well, what has to be below 6 so that it's the same as 2/3? 9, because I had to take 2 times 3 to get here, so 3 times 3. What has to be below 12 so that it's 2/3? 18. You do the same thing here. Reduce the given one, and that would be 3 over 5. So this would be 9/15 and 12/20. Or you can set them up as extended proportions and cross multiply. You'd get the same values. Are we good? Excellent. Make sure your name's on it and hand it up.